Hi guys and welcome to another video. So in this video we're going to talk about Numpy again. So in this playlist we're going to talk about what are some of the most common ways in which we use Numpy. So we use Numpy basically to create arrays. They are optimized, okay, so they are faster than Python lists, okay. So let's get started. So the first thing we need to do is to import NumPy. So to do that, if you have ever used NumPy, you pretty much know that we use import NumPy as NP, which is pretty much spread all over the internet. So let's do that. Let's import NumPy. It takes a couple of seconds, actually, depending on your computer. So there we go. So if you're using Python, you pretty much create a array of numbers using a nested list, something like numbers equal, and then you create a list. So let's create a list with these numbers. So if you call type numbers, okay, so this is a list. Okay, we could pretty much make let's, for example, numbers times 3. I never tried this before. Okay, so it does work, but it doesn't work as expected. So, but you guys will see why this happens. So we have this list, and it is very unoptimized. So if you are trying to make a neural network from scratch or simple mathematical operations, this is not a good idea. So that's why we have NumPy, because NumPy is faster. Okay, so let's say I want to convert this numbers list to a NumPy array. To do that, I could do basically numbers equal np.as array. I could do that array and pass numbers. So if I call numbers, it has changed. Now instead of class, instead of just seeing the numbers, I see this array, and then I see that the numbers inside of it. So if I call type numbers, I'm gonna see that this is now a NumPy ND array. Okay, so this is a native NumPy array now. So if I call NumPy numbers times 3, I'm gonna see that each number was multiplied by 3. Okay, so 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So as you guys can see, it's very, let me just increase this a little bit. I think you guys are maybe not be able to see the full example. So I'm gonna increase to a 22 font size. Okay, I think now it's better. So okay, so let's just so let's see what more we could show you guys. Okay, so let's say I want to create a simple array to initialize something like a word to vec. So I could do something like actually one hot encoding. So I could do v equal np dot zeros, and I could make a vector with 10 numbers. So if I call v, I have this v which has 10 numbers. If I call len v, I should probably see 10. Okay, so yeah, I'm seeing 10. Oh, let's just drag this to the top to help you guys visualize. Okay, so let me, okay, so we have this v, a vector. So this is a vector. Okay, so what we could do though to make something like a one hot encoding is basically to put a number 1, to put a 1 in some index. So list does have indexes, but it's not something that is very fast. So if I want to access the fifth element, I would do something like this, which is 0. If I want to set v6 equal 1, I could do this. If I call v, I can see the 6th element is now 1. Okay, so that's pretty much what's going on here. So that's lots of things that you guys can explore. So if I type np dot, let me see. Okay, I'm not able. Okay. So np dot and v, you could multiply v by by numbers. Okay, okay, we got an error, but that's expected because the shapes are not 9. So let's just create a simple neural network here. So if I have an x, which is going to be np dot array, two numbers, 0.2 and 0.6. Okay, so I have this x, okay, and I have a w, which is going to be random numbers, and the shape of this w is going to be 2 2, okay, or 2 1. So if I print x, I see d. If I if I type w, print type, I'm gonna see this. So we could multiply this. So if I do x times w, I'm gonna see this. Okay, which is a multiplication, simple multiplication. So I could, for instance, let's say that I want to see the activation function, that is the hyperbolic tangent of this multiplication. I could do something like this. Okay, so this is how you could usually create a neural network using Numpy or something like that. So the implementation of a neural network using pure Python code would be very slow and very difficult. So that's why using Numpy is a must do thing if you wanna really go deep into deep learning. So there you go, guys. I think this is good for a introduction. I'm gonna dive deep more into something like tensors, how to create multidimensional vectors or arrays using NumPy. So thank you guys for watching this video. See you guys next time.